We're live. All right. Sorry, some behind the scenes shenanigans in the chat box. All right. Hi, everybody. Welcome to AP Live, AP Calculus AV.
Hi,
Hey, Virg.
Mark. Ooh, transitions are on point today.
I am Mark Corelli at Ryan High School in Denton, Texas. And
I'm Virg Cornelius. I teach at Lafayette High School in Oxford, Mississippi.
All right. We are getting near the end of week, not 3. We're starting our 6th week, I guess, as I looked at it last night after Virg said, you said we were at this for 3 weeks.
Yeah, it's actually 20...
compared to 30 years of teaching, 3 weeks is like 6 weeks.
Yeah, right. It has seemed short, though, actually. When you enjoy something, it seems like it flies by. That's probably a big part of it, right?
We can go with that. I like that. Yeah, I actually got the calendar out. Was like doing the pointing thing last night. Like, really? Like flipping the calendar. Did I just add a week? Nope, that was just one. All right, so we're going to do some mixed review thoughts. We are going to talk about some resources that are available. So you can do some practicing away from us this weekend and next week. And tomorrow we're going to do something similar. We're going to try and get you oriented for what the test experience looks like and let you know what the exam prep next week's going to look like. This QR code, this bit.ly, take you straight to our calendar. If you want to go be, hey, I missed 7/7, you can go look at that calendar, see what day we did that, and then scroll through the YouTube videos.
Love the hexagons. Tiling a plane.
Yeah. It seemed mathy, right? This was our new slide yesterday with the test. We're going to actually go through this testing guide tomorrow with you a little bit, talk about what links are on there. This 4-minute video on YouTube will take you through the exam process, and there's the QR codes that take you to both of those, or these bit.lys if you want to go ahead and check those out and come back, or come back and pause this later and point your camera at those. Your smartphone does a wonderful job with those. All right. I think we're up to 2 days without a mistake. I didn't get any nasty emails yesterday.
And thinking that 5 weeks has been 3 weeks is not a mistake.
Oh, no. We're talking, that's not what this is for.
These are for egregious mathematical errors on our part.
That aren't corrected at the time, right?
Yes, that is true. Yep.
All right. So introductions and banter, as we've been doing ever since we've gone to review mode, we are warmed up. We are ready to go. That's why you're here. We're about to go through those classroom resources. Yesterday's shared folder had 3 FRQs in it, that 2 of which had been modified. We're going to do that 3rd one, and I'm actually going to be the one that does that. And then in the shared folder, there's a wonderful circuit from I don't know. It's Black River Math, I think, is the copyright.
It says Vicky Carter on there.
Our friend Vicky Carter, South Carolina.
Florence, South Carolina.
It is over tables and calculus. It's really cool. It's in there, and Virg is going to get you started on that circuit.
Yeah, good times.
All right. So this is something that you could probably find. It may have been emailed to some of you, but we just wanted to kind of go through, make sure everyone knew what's available in AP Classroom, particularly if your teacher hasn't been using it. Because if you've been using it, you probably noticed, hey, there's some new things here. But if you haven't been in AP Classroom in a few months, there's been some changes. It's myap.com. It's right, or myap.collegeboard.org. Not .com, that's silly. Or just Google My AP College Board. It shows up. You put in your name and password, and we move on. And then it should take you to a list of your classes. And this is where Virg and I are actually less familiar with, because we don't have the classroom account.
Right. These slides are brand new to us. Yeah. Well, like 3 days ago, they were brand new.
But you should scroll to AP Biology. You should scroll down here to AP Calculus AV. I said that earlier when my wife was in the room and got a hey. She's sequestered with the children right now.
And is an AP Bio teacher.
Yes, she is an AP Bio teacher. Click AP Classroom down here next to your course. It'll take you to the AP Classroom for that course. And then this is where there's some new stuff. The banner has had some things added to it. These are assignments that may have been given by your teachers. But there's the live the YouTube live streams right here. That'll actually say 2 to 2:45 for us, right? If you're, because they went to bio, but if calc. And then there's this optional practice, and you can read what it says to click there. So what happens is when you go to your assignments tab, and you can get there if you go to your assignment tab as well. The assignments has your assignments. That's the stuff your teacher has given you. Those will already be there. It'll be empty if your teacher doesn't use AP Classroom, and that's fine. It's a new resource this year. People are getting used to it. But this green bullseye has the optional student practice. That's the new tab, and that's where these new unlocked FRQs are. And looks like our friend C. Lawrence needs to continue this one, but you could also begin others. Slow me down if I go too fast, Verge.
No, you're actually going perfect speed. You're fine.
All right. So again, they're in a bio class, but they opened one of the questions, and there's a text box down here to enter it. This is not the same format as the exam. This is just the form for AP Classroom for these practice problems.
We're going to look at exam stuff tomorrow.
Exactly.
But, yeah.
It's funny. Your picture is right in front of click submit.
Oh, really?
So it just says then mit, which is then with in German, but or it's covering the word vomit. I don't know. It just was weird for me. Okay. When you finish a question, you enter your question down here. There's a submit button. And then this is where it may be different from assignments you've done with your class. Because then this thing comes up and says, are you sure you want to submit? Say no or yes, and you think you're done. But even if you click yes, it says, are you really sure? It says, do you want to see how this question is scored as an AP exam? Now you can either say no and just go ahead and submit it if you think your teacher's going to go over it with you at some point, or you can click yes, review. So after you've done the problem, you can review and then actually revise. So when you click review, the scoring guideline comes up, and that's what this looks like. And you'll notice up here on the tabs, there's a part A, a part B, a part C, and a part D. And you can actually score yourself and go, oh, the response includes this. And if you click that, it gives you a point. And if you click the second one, you get a point. So, this tells you what you should have put. You can compare it to what you thought you should have put. And if they match, yeah. If they don't, try to figure out what you're missing or if they're equivalent. A lot of times you have an equivalent. And then when you get done with that, you can say, yeah, okay, thank you. I'm going to go ahead and submit. Or you can, yes, review, which means now you can revise your answers, right? So, and I'm going to switch shares because that was that presentation. So
yeah,
I hope that helped.
Yeah, and that was helpful to me too as a teacher, because we don't get to see what the student portal looks like. And then of course the student portal has changed. So students can access that stuff from now all the way up until their AP exam for extra practice.
I should have used that time you were talking about that to change my background. I'm just going to go ahead and do it. All right.
Oh.
So we have question
great
3,
and powerful.
Our new question. It says the function f is defined by f of x equals the square root of 25 minus x squared for the interval from -5 to 5 inclusive, including the endpoints, closed interval. Find f prime of x. Write an equation of the line tangent to the graph of f at x equals -3. Let g be the function defined that g of x is this piecewise function f of x from -5 to -3 and x plus 7 from -3 until 5. And then is g continuous at x equals -3? And use the definition of continuity to explain. Then they're going to have us do 2 integrals, find the value of the integral from 0 to 5 of x times the square root of 25 minus x squared. That was our f of x from before. And E, find the value of the integral from -5 to 5, 6 times f of x plus 3 with respect to x. That E is new. This is from an actual former AP test. These were all adapted from AP Central. So teachers that are very familiar with this, it was a number 4 back in 2012. E is new for today, so little bonus. A, we don't suspect you'll see something quite like A unless it says verify or something like that, right, Verge?
Correct, because this can be done on the calculator. So Mark's going to do it analytically, which is important for your future. And then also show you how to do it on the calculator, because you might want to really make sure you know how to do a few of those things, since you will be able to use your calculator. I mean,
Okay.
again, we don't have any inside information, so I'm not saying
Yeah,
you.
we're just doing.
I'm just
what's
saying, like, just be
what we
prepared
see.
for a lot of different stuff.
Right. um, all right. So we're going to take this derivative analytically, as we said, and I'm just going to take the derivative of the left side. That's the easy part. And then I automatically see this as 25 minus x squared to the 1/2 and do a power rule every time.
Mhm.
Verge has said she just jumps to the 1/2 square root when she sees the square root. I'm going to do it the way I would do it.
Mhm.
Your way works, obviously. So 1/2 comes down from that exponent that was an understood 1/2, and I subtract 1. And then I look at my interior, and it's not just an x. So what does that mean, Verge?
Got to take the derivative of what's inside. Chain
Yeah,
rule, chain rule,
I
chain rule.
almost brought my stamp home. We cleared out our classrooms yesterday morning, and when I was packing up, I was boxing up my desk, and I almost put the chain rule in my bag to have it, but I was afraid I wouldn't be able to find it in the fall. So,
So times negative
our
2x.
Verge sent me the pens. Well, a few years ago, she bought a bunch of chain rule stamps, self-inking stamps, and gave them to her teacher friends.
Yep. And they have been used
Yes.
because chain rule is one of those things that it's hard for students to remember
I
to use
had
it.
I had a couple of very clever students a couple of years back who actually asked if they could snap their wrist before the first chain rule test.
I
Um,
think you're done.
yeah, I am. I could clean it up. I mean, we have a
I
half
might
and a
as well
2.
because you're going to need to use it in
Yeah,
the next.
it's a little dangerous, but yeah, you could, I absolutely AP exam, stop and move on. You've got 20 minutes to get through for 20, 25 minutes to get done with this problem. Move on. Um, it is going to clean up as negative x over the square root of 25 minus x squared, but that's
Which will be
fine.
more convenient for part B.
And if you look at the scoring guideline on this, I'm actually not going to write it because I don't want any of you to fade out during the videos and then check in later to go, oh, do we need that? But if you look at the scoring guideline that's going to go up on this probably over the weekend, they actually have a note that the domain for the derivative is -5 less than x is less than 5 without the equals, because you're not differentiable at the endpoints. They can ask it, but if just like units, if they don't ask for it, you absolutely don't have to state it. So understand that if they talk about the domain, that's fine. But if they didn't ask about it, that's not part of the scored response.
And I might add that we were going to show you how to do that on the calculator. I
I'm
really
actually going
meant
to do it here.
part B, right.
Yeah.
That was my mistake. I meant part
That's
B.
okay. Yeah, but I was going to do it here. You're right. So it says write an equation for the tangent line of the graph of f at x equals -3. And so I need a point and a slope, right? So I'm going to plug -3 into my f of x, and I get 25 minus -3 squared, which sounds a lot like the square root of 16, which is 4. It's a principal square root, so it's the +4. So we have the point -3, 4. And I need to have a slope. And of course, I could do this now that I have this analytical derivative. We could plug -3 in here, and it's not tough because we already know that bottom is going to be 4. But what if we hadn't done all this? So get out my trusty 84. I actually brought my Inspire home. I don't know if I'll touch it all summer, but it's over there along with my Casio, which I love. But I think this is the most popular, so we're going to go with this one. Somewhere on your calculator, you're going to have the ability to take a derivative. I'm going to show you 2 different places. Under the math menu, Math 8 and Math 9 are the real popular places to grab them. You can do numerical derivative and function integration right there. That's the numeric definite integral. Those are your 2 calculus things. So Math 8 and Math 9, a lot of kids memorize it because if you push 8 and 9, it'll jump straight to them. Of course, you can arrow down as well. When I'm messing with my own kids at school, I'll arrow down to 5 and then press 8 just to see who's paying attention.
Of course you do.
Of course I do. Because they're like, wait, wasn't it on 5? Yes, figure out what I did. All right. If you've got the new OS, if you've bought your calculator in the last 5 years, or you've got the black and white that's been updated, these alpha F1 up here, if you go to alpha F2, the derivative and integral are right there as well. And they even have these handy templates so you can see what you're looking for. So I'm going to go ahead and grab that number 3. And I want to do a numerical derivative with respect to x of 25 minus x squared at -3, and I really hope it's 0.75. Okay, and hey, how accurate do you have to be on the AP exam, Verge?
To 3 decimal places, rounded or
So
truncated.
anything I write after that 0.750 is not going to be read by a reader. So it is correct as far as it needs to be correct. Of course, the actual answer is 3/4, so there's some weakness on the calculator there. It's using, I believe, a symmetric sum, which is not one of the tested versions of the derivative that we use. And basically, the calculator goes until there isn't a change about this far down, and then it says good enough. Ooh, better recharge soon. Okay. So now we've got a point and a slope. I was asked to write a tangent line. So again, I'm going to use my one that Verge doesn't like this time, just because I like to vary it up.
It's not that I don't like it.
I know there is a big danger. I know there's a lot of people.
There's a lot of danger if you teach Algebra 1 that they would add those numbers and then distribute. It is perfectly fine and it's beautiful for really communicating what's happening.
Don't talk and defend yourself and write at the same time. How many times? There we go.
Okay, looks good.
And again, that 0.750006 would be fine right there, as well as, you know, if you want to be totally safe, you know, you could have however you wanted to write that, right?
Please no.
Okay.
That's just that's unnecessary.
Don't like it, but it would be fair. It would be fair on the exam. All right, so C, and C is I love C, and C is something we absolutely could see on this year's exam. Verge and I both expect tangent line is going to show up in some form, but you know, you're not going to be asked to find this new, you know, symbolically on the exam without some kind of catch about showing your work or something. But they wouldn't have to change C at all. C is not something you're going to be able to Google really easily and find answers in continuity. So,
and I don't know that in this whole time that we've been working on these lessons, we've actually justified or proved continuity at all. I mean, I can't think back to when we did, but maybe
we did the definition at some point because we had a notes page, and we may have had you know what, we may have had a problem in there that we didn't get to.
Could be. Yeah.
So, all right, just folding that over so I got some space and move my camera. Okay. So this is my C. It says let G be this new piecewise defined function. Let's go ahead and just copy that. And it's f of x, which again is that square root of 25 minus x squared. And we're x plus 7 for the remainder of the interval. And we want to ask, they're asking, is it continuous at -3?
Yeah, and I could see them say something like verify that it is continuous at -3 or verify that it's not.
Speaking of -3.
That should be a -3. Yeah. Okay, good.
Which I did on the calculator, but all right. Thank you, Minnesota. That was text. And then we want continuous at x equals -3. So what are the 3 bullets for continuity, Verge?
Well, I always do it in this order. Is f of -3 defined? I'm going to check. I'm going to check and see if there's a value where x equals -3 and f of -3. Is the function defined?
Well, in this case, it's g of -3. So that's why I'm just writing function.
True. And then I want to check, does the limit as x approaches -3 or whatever your value, x value is, does the limit exist? Like I got to check that. And that means checking the one-sided limits, even though we might not write it down like that. But we do need to check it from the left and the right. And then finally, we need to see, are those two equal to each other? When you check to see if the function is defined and you get 17, and you check to see if the limit exists and you get 17, does 17 equal 17? If all those things are true, then the function is continuous at x equals whatever.
And I put this in a thought bubble because this is absolutely something that I would encourage my kids to write off to the side, kind of generate yourself a checklist. But this by itself is not going to earn any points, especially in terms of F, because our question's about G. But not everything's about getting points. Some of it's about setting yourself up for success, right? So the function's defined. So G of -3. So I come over to my piecewise function and figure out which of these two intervals does -3 fall into.
Mm-hmm.
And it falls into the upper branch.
Mm-hmm.
So g of -3 is going to equal f of -3, which was 4. I did that back in the last section.
Mm-hmm.
So first bullet, done. Right?
Mm-hmm.
Now the limits. Well, I can't just take the limit of g of x because it has a potential break there, right? So we need to look at the limit as x approaches -3 from the left of g of x. Now, which of these is the left branch?
The one where the x values are smaller than -3.
Okay. And f of x is continuous from -5 to 5. So this limit is going to equal f of -3, which is 4. I guess I'll use the expression, but
Yeah.
because I can evaluate the expression, I can go ahead and make that jump.
Mm-hmm.
And then my limit from the right of -3, well, now it's the other fork, so it's the x plus 7, and that's just a line, so I can plug into that, and they're both 4.
Mm-hmm.
So the limit as x approaches -3 of g of x is 4. Check. Now, some of you may think the third bullet's already taken care of, but it's not. You and I now know, because we have this checklist, that we have satisfied everything, but the reader doesn't know that we know. So g of -3 equals 4 equals the limit as x approaches -3 of g of x. I don't need the equals 4 in the middle, but I've been making 0 sandwiches all week, so I thought I'd make a 4
I
sandwich.
know this one has a few more calories, I would say.
definitely felt
4
like it.
calories.
Burning some calories off.
You are
so
on fire, Mark.
We have hit
look at
all
that.
3 bullets. Now, tragic. I was on the question team for this one. A friend of ours who's from California by way of Virginia, now in Florida, I think. He was the QL on this. And tragically, what was the question?
Oh, is it continuous, right?
Right here.
So you have to answer the question. You never
There's a
answer
yes
the question.
or no question.
Uh-huh.
So yes.
So you have to say yes. Uh-huh.
G is continuous at x equals -.
Mm-hmm.
Don't forget to answer the question. It's,
Mm-hmm.
it's a shame. Still, we got like 2 of the 3 points or something like that.
Hey, and you know what I just thought of in terms of exam day?
No
you
idea.
can be reading the questions out loud for yourself. Yeah. And I think that would really help people to think about whether or not they had actually, answered the question, because they might hear themselves read the question, reread the question before you decide you're done with that part, and then move on to the next part. You can read it out loud because you're going to be at home, most likely, for most kids taking it.
Yeah, absolutely. That's a very good point. All right, so now we have an integral, a definite integral. And, whoa, I am going to do it both.
Boy.
It does not like where that paper is right now. There we go. Okay.
There you go.
I will do it analytically and then do it on the calculator, because you could do this on the calculator again, unless they freeze the direction, something, like show the U sub or something like that on the exam. First thing I would like to do is simplify if I can, try to distribute it, things like that. That's not going to work. So what I tell my students next is, which of these 2 parts of this product are more complicated? So do you think x is more complicated, or the square root of 25 minus x squared?
The square root of 25 minus x squared.
So that's the one I generally identify as my u.
That interior part.
Yes. You can actually use the whole thing, but you don't want to. And then
the objective is to make a problem simpler.
Right, exactly. So taking the derivative with respect, to each side here, we get our 1 du, and then derivative of 25 is 0 minus a 2x, and then a differential of x shows up. And that means dx is du over -2x. I could also solve it for x, right? If I solve it for x, I could do du over dx.
Oh, that's lovely. I never thought about doing it that way before.
Let's do that then. Okay. I actually like this. Actually, the person who texted me from Minnesota, I think will actually appreciate this better. She doesn't like it when they mix together. So Now when I plug that in, the dx's will cancel, and this will be du over -2. I'll just leave it for now. We'll do, let's leave everything in there and kind of see how it looks. I do not like the 0 and 5.
Yeah, because you're in this mixed stage.
We're in this mix now. Yeah, I think I'm actually going x equals 0, x equals 5, because that is kind of a messy situation I created. But these guys are going to go away, right?
Mm-hmm.
And using this up here, when x is 0, u is going to be 25. And when x is 5, 25 minus 5 squared, u will be 0. So I'm just plugging those in, evaluating for u to get my new bounds. And I get from 25 to 0, -1/2 u to the 1/2 du.
Mm-hmm.
Which, depending on how you feel about that, you could flip these and make this positive. I'm just going to go ahead and go with it. 2 plus 1 is 3, so we have u to the 3/2 times the 2/3. -1/2 is just waiting. From 25 to 0. I'm going to go off my page here in a second. And that's going to be -1/3 times 0 to the 3/2 minus 25 to the 3/2. Again, can stop, right?
Mm-hmm.
But we also don't have to do it analytically. So square root of 5, square root of 25 is 5, cubed is 125. 0 is just 0.
And then a negative times a negative is a positive.
Correct. Thank you. I was going to say something about leaving this, but yeah, it's fine. It'll come to me as eventually. Now,
let's see the calculator.
Calculator. See how close the calculator can get. It freezes up. You're still moving, so it's my camera. Okay.
Mm-hmm.
And if I'd put 25 minus x squared in my y, that would have been nice because I could have pulled that out now, but I can go alpha F2 and pull up my integral, or math 9. Most of my kids do math 9.
Mm-hmm.
And of course I can use the original now, so x.
In fact, I would.
Yeah. Yeah, because if I made a mistake going to u, then going to the calculator is just going to exasperate it, right?
Mm-hmm.
And it's thinking.
Oh.
And it should be 6s forever, right? It should be 41 2/3. But
yep.
Again, to 3 decimals, gorgeous, that 8-7.
Mm-hmm.
Oh well.
Oh well.
I imagine it's just an 8675309 that's been rounded up.
Jenny, so. I got your number.
Another deep cut from Mark and Verge on this last day of April 2020. It's May tomorrow.
7. Well, how old were you with that song? Like 2?
No, that was an 80s song. I was at least in my second decade already. It feels very strong end of elementary, early middle school.
Okay.
How old were you? Subtract 4.
I don't know. Something. You seem a lot younger though, Mark.
Tommy Two-Tone. Go look him up. It's actually a band, but we'll go with it. All right. Number E, the new one. This is fresh. Find the value, and this is one I think we could see this year, because now going to the calculator might, now you can go to the calculator for this, unless they said leave it in terms of pi or something like that.
Well, I think, you know what, f of x on this one, go ahead and draw f of x. Let's pretend we don't have an explicit formula for f of x. Pretend that we don't know that f of x is.
That's a good point.
Yeah,
that's a
of
really
course
good
it's
point.
a good point.
It's actually an infinite number of points, but we'll go with it.
But imagine you're given a graphical stem.
It's easy if you try.
And f of x is this figure, which all of us recognize as the top half of a semicircle. It's got Mark is having a little moment there.
Semicircle-ish, yeah.
So we're not given the explicit formula for f of x. What is that?
Oh, I was just trying to make it a little more symmetric.
Oh, okay.
I'm just turning it into a sketch.
So then if you were told to integrate from 0 to whatever it is. I don't even know.
It's
I gotta
negative
look at
5
it.
to
Oh,
5.
it's negative 5 to 5. If you were told to integrate from negative 5 to 5 of 6f of x plus 3 dx, and you're not given the formula, you need to recognize that as top half of a semicircle. You need to know area of a circle formula. That would be a good thing to make sure to write down on a study guide that you're making for yourself. If you're nervous about forgetting that in the moment, have that on a little study guide for yourself.
There's definitely one that shows up at multiple times in AB exams. And
Uh-huh.
by the way, just as a side for that, we had students who did recognize it back in 2012 and actually found this equation of the tangent line by just writing the equation of the line perpendicular to the radius at negative 3, 4.
Mhm. That's
That
right,
was
because that's
pretty
a
cool
property
because
of a circle.
it didn't say use part A. It just said
Mhm.
write an equation. And so there were some very clever students that knew their geometry and their
That's
algebra
awesome.
and their analytical geometry.
Mhm.
Okay, I'm going to break this up. I'm going to change it to 6
And
times
this is
the
why this
integral from
question's
negative
so
5.
good. Yeah.
Because now this should look very familiar to a discussion your friend Verge was just having with you.
Mhm. And I'm especially concerned about students just adding 3 at the end after they do this beautiful work with, figuring out the area of the semicircle, multiplying it by 6, and then just adding 3. They shouldn't be adding 3 to 75 pi.
And just because it's off screen, I'm going to.
Yeah. Mhm.
So it's a semicircle, and I should say of with
Oh,
prepositions. Okay, so, well, and this is just a rectangle. I've mentioned this several times this week, but I want to go ahead and just write it out as long as I write out that semicircle.
It's just like the plus C, though. It's this
Yeah.
something you can really get.
It's a rectangle of height 3 and width 10.
Mm-hmm. Because 5 minus negative 5 is 10.
Because if you sketched it, it's a constant function from negative 5 to 5.
Mm-hmm.
Okay.
You can anti-differentiate too and get that 3x if you
absolutely.
wanted to, or use your calculator and stick it in the math 9.
3 times 5 minus 3 times negative 5. I think that adds 15 plus 15. Yeah, hey, look at that. Math works. All right. And of course, this ends up being 75 pi, but we don't need that. But we thought that was a neat addition to this problem because that is definitely something more along the lines of what we might see this year, where you have to use some properties. And like Verge said, what if f of x given graphically? And then so it could either be a piecewise function and with line segments and all kinds of fun stuff.
Yeah. Or what if you're given f prime of x or something like that in a table?
Yeah.
And then you have to use fundamental theorem. So this circuit that's in our shared folder for today, we're going to go ahead and work. I worked this circuit. I've worked it many times. It's such a great circuit. But when I worked it, I was working it to try and think, oh, well, which ones should we do with them? And then I thought, they're so good, every single one of them. So we are starting at the beginning. So, and
it was funny. You normally warn me before you grab my screen.
Sorry, what did you
No,
want
it was
to show
fine.
them?
No, I just had a moment of what happened. I lost my signal.
I'm sorry, Mark.
Oh, no,
I was looking at my watch going, it's 1:35.
No, you're good. You're good. Go,
Okay.
go. You have a joke.
Okay.
We'll hold the joke for the end.
Oh, I can tell it now. Here's the joke. While people are getting their shared folder, maybe. It just goes like this. Don't discuss infinity with a mathematician because you'll never hear the end of it.
I like that.
Okay. Throw it in the sink. All right, so this is a great circuit written by Vicki Carter, who teaches in Florence, South Carolina, and it is Thursday, AP Live 27, blah. Okay, so she's given here on this circuit a table, a very large table of values, and the way circuits work, if you're just joining us, is you start in the very first cell, you do the problem, show whatever work is necessary, and then you search for your answer. Okay, I've already got these all numbered because I already worked it. You search for your answer, you call that number 2, and then you continue proceeding like that. But here we have let k of x is equal to f of x plus g of x. Find k prime of 2. If I want to find the derivative of a sum, I just go ahead and take the derivative of each derivative of a sum is just the sum of the derivatives. So k prime of x would equal f prime of x plus g prime of x. K prime of 2, which is what we're after, would be f prime of 2 plus g prime of 2. And then I need to go to my table and figure out what's f prime of 2. It's looking like pi, right?
Yep.
And then plus g prime of 2 is looking like 7. By the way, we've had so many things that we've talked about since all of this pandemic started. But one thing that teachers have not been complaining about, because they have so many other things to complain about, is how their students don't know how to draw pi. Students who draw pi like this, Mark, what are they communicating to us when their pi looks like this?
Maybe an R. I don't know.
Or maybe mu, right? I mean,
Yeah,
that's, to me, looks
yeah.
like the coefficient of friction.
I was thinking a lower cursive R. Yeah, that was.
Yeah. If you are one of the students who's been haggled by your teacher because you don't draw pi properly, I promise you it will not get read properly on the AP exam. So make sure that you
Just be careful. Yeah.
rectify that situation. Yeah. All right. So we're looking for pi plus 7. That's our answer. Okay. So pi plus 7. Again, I kind of already went through this. So I had labeled my number 2. There's my pi plus 7. All right. Now j of x is equal to 3 g of x minus 2 f of x, and I'm trying to find j prime of 1. And this is the same exact table. It's just on the next page, just for ease of the student working it. So these coefficients are just along for the ride. I feel like I've heard Mark say that. Is that what you say, Mark?
Yeah, I do.
So I'm just bringing down, it's not a product rule, because I could do a product rule on 3 g of x, but I would zero out one of my terms. So it would be just too time consuming to do that. I'd rather just go ahead and bring my coefficients along for the ride. All right, what is g prime of 1? What is f prime of 1? Let's see, g prime of 1 is 4. F prime of 1 is -3. So it's looking like 12 plus 6 or 18. Yes? Yes.
Yes.
Okay. So here's my third one. And the notation's a little different. Find d dx of g of x h of x, and then evaluate it at x equals 1. Well, you know, either way, whether you see the prime or whether you see the d dx, you're being asked to take the derivative. That's not exclusively true on this whole circuit, but in this case, I am being asked to take the derivative. And what kind of a rule am I going to need here, Mark?
It looks like a product.
Yep. So I've got to do first.
I thought about being cute about the no dot with those X's. It's really weird looking. Yes, it's fine.
Yeah. I think on the AP exam, they usually have a fairly large dot. So it's obvious that it's product rule, but still. So first times the derivative of the second plus the second times the derivative of the first. With all the multiplications, I'm not using those parentheses right now, just for clarity. So g prime of 1 times h of 1, and then plus h of 1. Something's wrong. First, this is wrong. I'm talking and I can't do math at the same time, obviously. Hold on a second. First times
everyone that says we make so many mistakes, it's like, well, we're writing, we're not at a chalkboard or a whiteboard. It's different.
Okay, you want to know how often I've done math sitting down in the last 30 years?
Yeah, exactly.
Probably like about 8% of the time. You know what I mean? Like I am usually not sitting, and it's not good. I'm gonna have to go to a chiropractor or something. Okay, anyway, g of 1 times h prime of 1, and then plus h of 1 times g prime of 1. And again, got to look up in the table to figure out your values. So g of 1 is 2. And then h of 1 is, I know I'm off screen, h of 1 looks like 7, or sorry, h prime of 1 looks like 5. And then h of 1 is 7. And then g prime of 1 is 2.
G prime of 1?
Yeah, not is 4.
G of 1 was 2.
Okay, sorry.
It's all right.
Okay,
that's why there's why we have 2, right?
That's why I worked in advance too. Look, that's 38, and I probably couldn't find, you know, a 28 or whatever. All right, so let's see if I can find the 38 for problem number 4. Oh, yes, indeed. This is exactly what I wanted to see. Evaluate the definite integral from 2 to 4 of h prime of x dx. Math 9 is not going to help you here, right? You need to know what to do here. What should I do?
Why don't you just go ahead and try and use the fundamental theorem of calculus?
Yeah, this is equal to h of x evaluated from x equals 2 to x equals 4. That's the fundamental theorem of calculus, what many books call part 2. And the other anyway. But yeah, so now I'm going to say h of 4 minus h of 2. So I want to look up on my table for h of 4. I'm going to go ahead and pull it down because it's not too far away. So h of 4 is equal to -5, and then h of 2 is equal to -3. So it's looking like -5 minus -3. So I'm looking like -2.
Mm-hmm.
Is that good? Okay, so now I'm looking for -2, and that becomes my 5th problem. Oh, there it is. Yep, there it is. Okay, what kind of rule there? ddx of f of x divided by h of x when x equals 2.
You're finding a quotient.
Yep. So, low-de high, mine high-de low. Oh, low, low. Low-de high. Low times the derivative of the numerator. Mine high-de low. Oh, low, low. Over the denominator squared. Quotient rule. Mark doesn't sing to his kids. Oh, well.
No, it's not. Oh well, it's to save them.
All right. So now I'm going to take a look at h of 2, and I'm playing with fire here because I'm going to not actually write h of 2, and maybe Mark can comment on that while I do this. Why is this kind of playing with fire if I don't write h of 2 right now? In terms of AP
reasons.
grading.
Knowing where the values came from. If she gets them right, it's going to be okay.
Yeah,
but the formula above may not be worth the points, as many points as the with the symbolic. There's some other things too, like she doesn't want to write equal to this necessarily because, well, I guess it had the x equals -2 in the evaluation bar there as well. But honestly, you could have put the 2's in as you were going, since I had the when x is 2 on the original statement, right?
Yeah, that's a good point. I could have just put the 2's all right there.
But only because that bar is there. That's
yeah, that connected to the problem. Okay, so h of 2, what did we say that was? H of 2 was -3. So that's a 9 in the denominator. -3 times -3 is +9. In the numerator, it looks like we're going to have a positive
4 minus 3 pi or something. Like that.
Yep. So there's my answer, -3 pi plus 4 all divided by 9. So looking for that, she taking us back to the front probably. Yep.
Yep. And she did rewrite it the way I had said. That's just luck. I hadn't actually looked at that.
Yeah. This one's another product rule, and we are kind of getting close to being done. So I'm going to actually do a chain rule one instead. In fact, let's do this one right below it.
Yeah, and we'll have 6 of the 12, so that'll give you guys some stuff to do tonight.
Yep. And we'll probably come back and visit at least a few of these tomorrow, in addition to doing some more calculus and talking more about the nuts and bolts of the actual exam day. But
and that is the Michigan come out of me. It should be you guys and gals, right?
You guys and gals. Okay.
Guys is genderless in Michigan.
Let W be the function given by W of x is equal to this integral from 1 to h of x of f of t dt. Find the value of W prime of 3. Okay, so we've done this a lot recently, it seems, but in the context of maybe having a graphical stem where we have to talk about concavity on a function or something like that, or increasing, decreasing. I need W prime, so I need to take the derivative. Like Mark said earlier, it's easy to take the derivative of W of x, right?
Yes.
It's just going to be W prime of x. But the derivative, and I'm just going to actually kind of show it, The derivative on the other side is definitely a little bit more complex. This is fundamental theorem of calculus, what many books call part 1. Taking the derivative of this definite integral is kind of like doing an inverse operation. They kind of cancel each other out. This upper bound needs to get substituted into your function everywhere you see that independent variable. So the t is the independent variable. Because this upper bound is complicated, more complicated than just x, I need to multiply by the derivative of it. So this is a chain rule situation in addition to fundamental theorem.
Always make sure that inside is not just an x when taking a derivative, right?
Yes. So this ends up being f of h of x and times the derivative of h of x, which is going to be h prime of x. Is going to be f of h of 3 times h prime of 3. So when I look up at my table, h prime of 3 appears to be negative 3/4.
Yep.
And then h of 3 appears to be 1. Yep. Oh boy. Now I got to figure out f of 1.
It's
so
4.
F of 1 is 4. Oh, this is pretty now. 4 times negative 3/4. Final answer there, negative 3.
Nice.
Yeah. So this a lovely set of exercises there to finish off or start again at the beginning and see how well you do. Okay. Other comments that we want to make before we kind of close out for the day?
No, other than a nod to the home state that I could have avoided the whole guys gals things if I'd just gone with y'all.
Am I the home state or you? I guess
my
we're
home,
both...
my home state. Y'all,
Yeah.
y'all's nice and generalist, but
all y'all.
All right. So.
Yeah. So tomorrow, a lot of nuts and bolts on what test day is going to look like. We actually have a meeting tonight about it, and also more ideas about what next week is going to look like. We're meeting every day next week. There's going to be mock exams administered during some of those lives. So more commentary on that, but more calculus, most importantly, right?
And some more details tomorrow because we're getting details this evening.
That's right.
Yeah. Again, there's the QR codes to a little information if you do a little digging before tomorrow. There's the QR code to our Dropbox, so you can get this wonderful circuit or go back to yesterday's stuff and get those 3 FRQs and try to see if you can recreate them on your own. And thanks for watching. Bye, Verge.
Thanks for watching, and we'll see you tomorrow. Bye, everybody.